Imagine the sky darkening in the middle of the day, the temperature drops, and the birds fall silent. This is the awe-inspiring phenomenon of a solar eclipse. It is a moment when the cosmos aligns in a spectacular display. For a brief time, the sun's brilliant face is hidden. This event has captivated humanity for millennia. A solar eclipse occurs when the moon passes directly between the sun and Earth. This alignment casts a shadow upon our planet. It is a precise celestial dance. The moon, though much smaller than the sun, is also much closer to Earth. This difference in distance creates a remarkable visual effect. From our perspective, the moon can appear to perfectly cover the sun. This precise alignment is not a frequent occurrence. The moon's orbit is tilted relative to Earth's orbit around the sun. Eclipses only happen when the orbits intersect at the right time. Not all solar eclipses are the same. The appearance depends on the exact alignment and distance of the moon from Earth. There are four main types. A total solar eclipse happens when the moon completely blocks the sun's face. This is the most dramatic type. It can only be seen from a narrow path on Earth's surface. An annular solar eclipse occurs when the moon is farther from Earth in its orbit. It appears smaller than the sun. The moon covers the center, but a bright ring of sunlight remains visible around the edge. This is called the annulus. A partial solar eclipse happens when the moon only covers a portion of the sun. This can be seen from a much wider area than a total or annular eclipse. The sun appears as a crescent shape. A hybrid solar eclipse is a rare type. It shifts between being a total and an annular eclipse along its path. This depends on the curvature of the Earth's surface. For a total solar eclipse, you must be within the path of totality. This is a narrow band, typically only about 100 miles wide. Outside this path, observers will only see a partial eclipse. The moon's shadow races across the Earth's surface at thousands of miles per hour. The duration of totality in any one location is usually only a few minutes. It is a fleeting but unforgettable experience. The path of totality is different for every total solar eclipse. It depends on the specific geometry of the sun, moon, and Earth at that moment. Predicting these paths requires complex calculations. Scientists use precise orbital mechanics to forecast eclipse paths years in advance. This allows people to travel to be in the right place at the right time. It is a testament to our understanding of the solar system. The magic of a total solar eclipse lies in what is revealed. As the last sliver of the sun disappears, the sun's outer atmosphere becomes visible. This is the corona. The corona is usually hidden by the sun's overwhelming brightness. It is a wispy, ethereal halo extending millions of miles into space. It is incredibly hot, much hotter than the sun's surface. During totality, you can also see the chromosphere. This is a reddish layer just above the sun's surface. It is briefly visible before and after totality. Other phenomena appear too. Bright points of light around the moon's edge are called Bailey's beads. They are sunlight shining through valleys on the moon's edge. Just before and after totality, a single bright bead remains. This creates the stunning diamond ring effect. It is a signal that totality is about to begin or end. Looking directly at the sun, even during an eclipse, is extremely dangerous. The sun's rays can cause permanent eye damage. Special precautions are essential. Never look at the partial phases of a solar eclipse without certified eclipse glasses or viewers. Regular sunglasses are not safe. They do not block enough sunlight. During the brief period of total totality, when the sun is completely covered, it is safe to look directly at the corona. However, as soon as the first bit of bright sunlight returns, immediately put your eclipse glasses back on. Using cameras, telescopes, or binoculars requires special solar filters. These filters must be specifically designed for solar viewing. Attaching a filter to the front of the lens is crucial. Always supervise children closely during an eclipse. Ensure they understand and follow safety instructions. Protecting your vision is the most important aspect of eclipse viewing. Solar eclipses offer unique opportunities for scientific study. The brief blocking of the sun allows researchers to study the corona in detail. This region is still not fully understood. Scientists use specialized instruments to analyze the corona's temperature, composition, and magnetic fields. Eclipses provide a natural occulting disk, better than artificial ones used by coronagraphs. Historically, eclipses have been used for other scientific tests. In 1919, observations during a total solar eclipse provided evidence supporting Einstein's theory of general relativity. The bending of starlight around the sun was measured. Studying animal behavior during eclipses is another area of interest. Many animals react to the sudden darkness and temperature drop. They may exhibit behaviors typically seen at dusk or dawn. A solar eclipse is more than just a scientific event. It is a profound experience that connects us to the cosmos. It reminds us of our place in the universe. Witnessing the sun disappear and the corona emerge is deeply moving. It is a rare spectacle that inspires awe and wonder. It brings people together to share a moment of celestial beauty. Understanding the science behind eclipses only enhances the experience. It transforms a mysterious event into a predictable, yet still incredible display of cosmic mechanics. So, the next time a solar eclipse graces the skies, remember the science at play. Prepare safely and take a moment to marvel at the extraordinary alignment above. It is a reminder of the dynamic and beautiful universe we inhabit.